Hello friends, in this video we will discuss about stress strain curve. For that we will start with stress. When any external forces are applied on a body, it will deform the body. It will try to change its shape, but the body will will resist this deformation. This is due to the cohesion of the particles of the material. So this resisting force is equal to the applied force. This resisting force offered by body to the deformation per unit area is called as stress. So let's assume P is tensile load applied on a cross-sectional area A. So our stress equal to resisting force P divided by cross-sectional area A. So stress equal to P by A. Unit of stress is Newton per meter square or Pascal. Next is strain. Strain is the deformation per unit length in the direction of deformation. Here in this figure, the bar of length L is subjected to tensile load P. It undergoes deformation delta L. So our strain equal to delta L by L. As it is the ratio of same dimension, it is unitless. Next important is stress strain curve. This is the mild stress strain curve. When it is subjected to tensile load, it undergoes deformation or elongation. First, when we increase the load or stress, the stress is directly proportional to strain. This proportionality line is called P up to P. It is called proportionality stress. Next is E, elastic stress, where in this region Hooke's law is applicable. Hooke's law states that under elastic limit, stress is directly proportional to strain. Means, in this region, if the load is applied, the deformation is disappear after the removing the loads. So, this type of deformation is called elastic deformation. Next point is Y, which is called as yield stress. Here, we observe reduction in the stress for the further deformation or strain. This is called as yield point. This yield stress we take for the calculation of design of strength or materials. Next is ultimate stress. It is the highest stress observed in the material during the deformation. This region is called strain hardening region. From Y to U, it is strain hardening region. Next, when we further increase the stress, there is reduction in the cross-sectional area. Therefore, stress value is also further reduced. This region is called necking region. The phenomenon of reduction in the cross-sectional area due to stress is called as necking, which is this is the indication of failure of the material. And at point F, material will fail or fracture into two parts. So, the point F is called fracture stress. This is the complete graph of stress strain for mild steel. But if we consider, there are two types of material, brittle material and ductile materials. Both they shows different type of deformation. What happen in brittle material is, here the ultimate strength is less than the fracture stress. Therefore, it fracture in two parts before the ultimate stress occur. This region is called as toughness. It is the energy absorbed before the failure is toughness. F is the fracture stress. Here we can see there is no plastic deformation or shear deformation. This happens in brittle materials. Whereas in ductile material, there is large plastic deformation occur. So they called as ductile materials. In this material, toughness is very high. Up to point F, the area of under this stress strain curve is called as toughness. Here the ultimate stress is greater than the fracture stress. Ultimate stress is greater than the fracture stress. is called as ductile materials. So these are the two type of fracture observed in brittle and ductile material. Next is stress strain curve for various material. As we know, different materials have different properties. So the glass, aluminium, mild steel, rubber, these are some examples. Glass and rubber are the brittle material which show less plastic deformation. Glass is strong material, rubber is less strong. Therefore, it undergo deformation under low value of stress compared to glass. This is stress strain curve for aluminium and aluminium alloys, and this is the stress strain curve for mild steel. So anybody asks to draw stress strain curve, you should ask which material, because stress strain curve is different for different material. With this, we complete our lecture. Thank you.